Here's a perception test. Are you ready? First, can you see the hidden tiger? Second, who do you see here? Third, squares or circles? And lastly, read this sentence. The term cognitive has come to mean mental processes, or in other words, thinking. And so, cognitive psychologists are interested in studying internal mental processes and how mental processes are involved in behaviour. Internal mental processes can be defined as private actions or processes of the mind that mediate, come between, stimulus and response. These mental processes include things like perception, memory, language, problem solving, and attention. So let's see how well you pay attention in this video. Behavioural psychologists such as B.F. Skinner, who we've explored in other videos, argued that because our mental processes are not something that can be directly observed, then we cannot study them scientifically. However, the cognitive approach, who developed in the 1960s as a response to the behaviourists' failure to acknowledge mental processes, argued that mental processes can and should be studied scientifically. They argue that this can be done indirectly using inferences. The word inference is a key term to understand in relation to the cognitive approach. An inference is drawing a conclusion about the way mental processes work, which we cannot directly observe, by making assumptions based on behaviour that we can directly observe. Cognitive psychologists use scientific methods such as lab experiments to investigate the human mind. So let's conduct a couple of mini experiments together to illustrate inferences. First up, the Stroop effect. You're going to need the stopwatch on your phone for this. In a moment, I'm going to put a list of words on the screen. When I say go, you start your timer. Your task is simply to say the word aloud and not the colour. For example, if you see this, you would say blue, green, orange aloud, just like I did. You've got to complete the whole list of words as fast as you can, and you press stop when you've said the last word. Just to be clear, you are to say the word, not the colour of the word. Here's your first list. Timer at the ready. Go. Easy, right? Make sure to write down somewhere how long it took you. Now let's do that again with another list of words. But this time you have to say the colour of the word, not the word. For example, if you see this, you would say red, blue, green aloud, just like I did. Got it? Timer at the ready. Go. So how did you do? Which list did you complete the quickest? Researchers have found again and again that it takes people on average longer to say the second list than the first list. Now let's think about this in terms of inferences. What can we conclude from these findings about our mind? We cannot directly observe the mental processes that are going on in your mind, but we can observe your behaviour. In this case, the observable behaviour was the time taken to complete the task. There is no subjective opinion here, this is an objective measurement. So what conclusion can we draw about your mind based on your observable behaviour? It appears to suggest that our mind has a preference for the processing of words over the colour of the word. Why might this be? Well, what if I told you that a 7-year-old can complete the second task faster than both you and me? What might that suggest? The Stroop effect suggests that our mind wants to understand words first, and this makes sense given the education we've had from very early on in life, emphasising the importance and the priority of reading. And that's why younger children who have had less reading experience can complete the task faster. Let's do another experiment, this time into the capacity of your short-term memory. I'm going to present a list of numbers on the screen which you need to read, and then when and only when I make them disappear from the screen, you can pause the video to try and recall them by writing them down. I will then present you with another list of numbers. We're going to do this 8 times, and at the end I'll reveal all the numbers so you can check how many you got right. And you've got to really concentrate for this. So, pen and paper ready, or phone ready? Here we go. Make a note of where you made your first mistake. So this task is designed to measure the capacity of your short-term memory. We cannot directly observe your memory at work, but what we can do is observe your behaviour in terms of how many numbers you correctly recalled, and then see at what point you started to make errors. From this, we can draw a conclusion about how much your short-term memory can hold. George Miller in 1956 published a paper called The Magical Number 7 ± 2. In this paper, Miller proposed a theory, as the name suggests, that the average capacity for short-term memory was between 5 and 9 items, or what he called 7 ± 2. Let me know if any of you managed to score higher than 7 in the comments below. Now, earlier in the video, I said that we would see how well you were going to pay attention. Since I said that, several things have changed during this video, and I wonder how many of them you've noticed. For example, I've changed my t-shirt 3 times. I started in a white t-shirt and somehow I'm in this one. And maybe some of you noticed that because you were looking out for it. But what else did you see change? Did you notice how the colour of the light behind me swapped over? And what about the toy panda on the bookshelf over here who's become Peter Rabbit? And then at some point in the video, a large toy giraffe appeared nibbling on the leaves of my plant. When did that appear? What we don't pay attention to, we don't see. And what about that hidden tiger image I showed you at the beginning? Did you see it? Take a look at the stripes on the tiger. It says, the hidden tiger. Right in front of your eyes, but because you weren't looking for it, you couldn't see it. The development of the first computers gave cognitive psychologists a metaphor for describing mental processes. Mental processes are regarded as information processing, with the mind operating in a similar way to a computer. Computer models refer to the process of using computer analogies as a representation of human thinking. The computer model allows mental processes to be thought of in terms of inputting information, processing that information, then storing it, and finally retrieving or downloading the information. In human terms, information is input through our senses, which is then processed by the brain. It can then be stored in our memory and can then be retrieved from memory through either recall or recognition. Additionally, cognitive psychologists use theoretical models. The word theory simply means a system of ideas intended to explain something. So cognitive psychologists create models that try to explain the way our mental processes work. These models are simplified representations based on current research. Theoretical models often show the stages of a particular mental process. As mental processes cannot be directly seen, models help to represent different aspects of the cognitive system. For example, here is a famous model relating to memory. It's called the multi-store model. Isn't this the most beautiful model you have ever seen? This model tries to show how memories are processed. As the name suggests, the multi-store model proposes that there are multiple, or separate, stores for 3 different types of memory: sensory, short-term memory, and long-term memory. And that information goes through each of these stores in a linear pattern. Notice from this model how you have the computer model idea of input, process, and output. This model suggests that memory enters through our senses, and then is passed to our short-term memory, but this only happens when you pay attention. Then when information is rehearsed, we can temporarily keep it in our minds for a short period of time. Then for it to go to long-term memory, the information needs further rehearsal. And then, if we got asked about that information in an exam, for example, we would then retrieve that information from long-term memory to short-term memory to be temporarily used to answer the question. For example, consider the Stroop effect we talked about earlier. You may have never heard of that before, but through this video, information has come in through your eyes and ears. If you were paying attention to the video, this information would then have gone to your short-term memory, which you would have needed to complete the Stroop effect task. At the end of this video, there are going to be some questions to help you check your understanding, which is a great way to not only see if the information has gone into your long-term memory, but also a great way to strengthen and consolidate your understanding of the Stroop effect. Having theoretical models allows psychologists to provide testable theories about mental processes, and these can be studied scientifically. Lots of research has been done to test the accuracy of the multi-star model to find out how well it explains memory, and since then newer models have been proposed that have improved our understanding. Now, a fascinating aspect to our mental processes relates to the role of schemas. Mental processes like perception and memory can often be affected by our expectations and beliefs. Schemas are organised units of knowledge that we have developed through experiences. They help us to make sense of the world so that we can predict what is going to happen and know how to respond appropriately. They're a framework through which you and I can interpret information. Let's imagine a young man is on a date with his girlfriend and he's taking her out to a restaurant. Can you think of everything that is going to happen from the moment the girl arrives outside the restaurant to the moment they sit down at the table? What do you expect to happen? Well, because he's a classy guy, he opens the door for her, of course. Then, as soon as they enter, the waiter arrives and asks, "Have you booked?" And because he's a gentleman, of course, he's booked. The waiter then shows them to the table, and being the classy guy that he is, he pulls out the chair for her. The waiter then asks if there's anything they would like to drink before giving them each a menu, lady first of course, and explains the specials for the day. Notice how you and I have a schema for a restaurant. We know what to expect because we have built up through experience an organised unit of knowledge specifically for restaurants. Now let me ask you this, is McDonald's a restaurant? Well, technically they call themselves a restaurant, but we all know that McDonald's is different from your typical restaurant. I mean, can you imagine entering McDonald's and standing at the door until a waiter comes to ask if you've booked? And then when you walk over to the table, you go to pull the chair out for your girlfriend and you can't because someone's nailed it to the floor. Now, as you have probably begun to appreciate, schemas can be very useful. They enable us to process lots of information quickly, and this is useful as a sort of mental shortcut that prevents us from being overwhelmed by environmental stimuli. They work on the basis that we try and process stimuli in the simplest and most economical route possible. Schemas also help us predict what will happen based on our past experiences, which also helps make life simpler. Can you imagine not having a schema for a restaurant? Every time you turn up, you've got to figure out what the protocol is. However, schemas do sometimes have their downside. This is because they can often distort our interpretation of sensory information. Research into perception has found that participants' interpretation of what they may hear or see is influenced by their expectations. For example, have another look at the picture I showed you at the start. Did you see a young woman or an old lady? Researchers found that if you are shown images associated with a young woman before seeing this image, you unsurprisingly see a young woman. But the reverse is true if images associated with an old woman are presented. How you perceive sensory information can be influenced by your expectations. For another example, do you remember what that sentence said that I showed you at the start of the video? Want another look? Now, what did it say? Did you notice the two thes? If you didn't, that's because you have a schema for what a sentence should look like, a set of expectations based on your previous experiences of reading sentences that helps you to predict what is there and speeds up your reading ability. However, the downside to this is that you can miss things that are right in front of your eyes in plain sight. This can be a very serious problem when it comes to eyewitness testimony. When we recall events we've witnessed, we are not simply rewinding the video in our mind and pressing play. Memories work by being reconstructed in our minds, and during this reconstruction, sometimes they are influenced by our schemas, our expectations of events. Check out the video where we evaluate the cognitive approach to see how this knowledge has been applied in order to improve the way the police conduct interviews. Schemas can also have an impact on an individual's mental health, where we can develop a negative schema about ourselves, which is one part of Albert Beck's theory of depression. We've explored this in videos on the topic of psychopathology, where we looked at cognitive explanations of depression. I'll link that video in the description below if you want to check that out. We can develop our understanding of human behaviour further by combining cognition, our mental processes, with biological processes. This brings us to cognitive neuroscience. Cognitive neuroscience is the scientific study of the influence of brain structures on mental processes. The word neuro relates to the nervous system, particularly the brain. So cognitive neuroscience looks at the possibility of how mental processes relate to brain structures, trying to figure out which parts of the brain may be involved in specific cognitive mental processes has somewhat of a history in psychology. For example, in the 1960s, French physician Paul Broca conducted a case study of a patient called Louis Victor Le Bon, otherwise known as Tan, because Tan was the only word he could clearly pronounce. This patient had lost the ability to produce speech, but had no problems hearing and comprehending speech. After Tan died, Broca conducted a post-mortem examination of his brain and discovered a lesion in the left frontal lobe. Broca discovered this also in a number of other patients, which led to the conclusion that the specific area of the brain must be responsible for speech production, linking the cognitive mental process of language with a biological structure. With the relatively recent development of technology, particularly with respect to brain scanning techniques, psychologists have the ability to explore cognitive neuroscience like never before. For example, fMRI machines can observe the activity of the brain at the same time as someone is performing a mental process. The famous memory researcher Endel Tulving reported that data from studies that use PET scans to monitor the blood flow of the brain found that when participants thought of episodic memories, these are personal autobiographical memories such as what you did on your birthday last year, a different part of the brain was activated compared to when participants thought of semantic memories, and these are fact-based memories with no personal reference, such as the capital of Sweden, Stockholm. This nicely related the different types of long-term memory to different biological structures. For another rather fun example, researchers at Stanford University conducted what they called the Love Competition, where they invited different people of varying ages to think about the people they most love in the world whilst their brain was being scanned in an fMRI machine. They were able to identify which individuals loved more deeply in comparison to the others by measuring the level of activity in the dopamine, serotonin, and oxytocin pathways in the brain, linking an emotion to a biological process. It's a fun video. I'll put a link to that in the description too, so you can go and check it out if you want. And a quick side note here, you can see from the examples we've covered that cognitive psychologists can use a range of research methods to study human behaviour. This includes lab-based experiments such as those researchers conduct into the Stroop effect or the capacity of short-term memory. They can also conduct case studies, which are in-depth analysis of an individual or a small group of people, often with an unusual or rare case, such as patient Tan. And then specifically with cognitive neuroscience, we can see them combining cognitive and biological processes with brain scanning technology for things like memory in the research of Tulving and the emotion of love in the research at Stanford University. Each of these ways of studying human behaviour have their strengths and limitations, but that's something we cover in the next video when we evaluate the cognitive approach. So now let's test your understanding of what we've covered about the cognitive approach in this video. A question will appear with a few seconds for you to pause the video before the answer appears. Here we go. Question 1. What does the word cognitive mean? Question 2. Name 3 examples of internal mental processes. Question 3. In relation to cognitive psychology, define what is meant by an inference. Question 4. Define what is meant by a schema and give an example. Question 5. Explain how schemas can be useful, but also how they can potentially lead to errors and mistakes. Question 6. What is meant by cognitive neuroscience? Describe an example of this to demonstrate your understanding. So now that you hopefully understand something of the cognitive approach, bear in mind the limits of your mental abilities, particularly in terms of your attention and how easily schemas can influence our behaviour.